मुझे अत्यंत हर्ष हो रहा है कि ये इंडिया इंटरनेशनल साइंस फेस्टिवल 2025 के अंतर्गत आयोजित सर्कुलर इकोनॉमी सेशन के इस इनॉग्रल सेशन में आप सभी का हार्दिक स्वागत करता है। Today we are joined by 120 outstanding participants selected from across the India representing diverse scientific and technological fields. आपकी उपस्थिति इस मंच को विशेष महत्व देती है। We are truly honored to have among us Dr. N.P. Shukla ji, former Chairman, Commission of Air Quality Management. Dr. Rajesh Gokhale ji could not reach; they may be coming soon. श्री राजीव कुमार सिंह जी, चेयरमैन मैनेजिंग डायरेक्टर हिंदुस्तान कॉपर लिमिटेड। इनके अनुभव और विचार इस फोरम को दिशा तय करने में अत्यंत प्रेरणादायक होंगे। I also warmly welcome our other distinguished experts of the day, Shri Ashish Panpalia ji from Ultratech Cement, Dr. Manoranjan Mohanty ji from Base to Wealth Mission, Dr. Satish Pandey ji, CRRI, and Dr. Adarsh Pal Bij, former Chairman, Punjab Pollution Control Board. इन सभी विशेषज्ञों की उपस्थिति से आज की चर्चाओं को और समृद्ध बना सकेंगे। डियर पार्टिसिपेंट्स, ये मंच आपके लिए सीखने, संवाद करने और सहयोग करने के लिए अवसर लेकर आया है। I encourage you to engage actively, ask questions, share ideas, and explore solutions that can create real societal impact. On behalf of IISF and the organizing committee, मैं आप सभी का हार्दिक स्वागत करता हूं और इस सत्र की सफल एवं प्रेरणापूर्वक शुरुआत की कामना करता हूं। थैंक्स एंड धन्यवाद।
Thank you, Professor Sanjay Gautam, for welcoming the participants. So now I request Dr. N.P. Shukla to deliver his opening remarks, and sir also will introduce the keynote speakers of this plenary sessions. So over to you, sir, please.
Thank you very much, Dr. Lakshmi Kumar. And for today's session, that our keynote speaker is Shri Sanjeev Singh ji, Chairman and Managing Director from Hindustan Copper Limited, Kolkata. Shri Rajesh Gokhale ji is also, we are expecting any time here, and he is also one of our keynote speaker. And we have here Dr. Ashish Panpalia ji. He is the cluster head of Hindustan Copper Limited. So in this plenary session, we have three deliberations, and you all aware that circular economy is critical at a time when the world is witnessing rapid depletion of natural resources. जो हमारी प्राकृतिक संपदा है, बहुत तेजी से उसका क्षरण हो रहा है। We have only one earth, whereas our requirements are increasing in a very fast rate, and in such condition, if it will continue, then we will be requiring more than one earth. So we have a limited resources on earth, and there is a need of judicious use of these resources. And why this depletion of resources? You are aware that it is all because of population spurt, then industrialization, urbanization, and also in infra activity, that as I said, increasing lot of waste generation is there, then environmental degradation is there, similarly loss of biodiversity and climate change. So these are all problems we are facing day to day. To overcome with these problems, there is a solution in circular economy. And you are aware that circular economy is not only environmental agenda. In fact, it is an economic opportunity offering minimization of environmental harm, creation of economic value, employment, and social being. So this circular economy became very, very important in today's scenario. And in such condition, discussion on this aspect is essential to have effective strategy to overcome with this problem. And circular economy, it includes product designing with longer life. And you know that till now we were using linear policy, take, make, and dispose. So that is not viable now. And in such condition, we have to think of this circular economy. And this circular economy, it is promoting reduce, reuse, recycle, and recovering resources at the end of the product life cycle. So in such condition, we have to maximize the use of our resources. And circular economy, in fact, it is based on 3 essential principles. That is, design out waste and pollution. In design stage itself, we have to decide that this should not this should not create pollution, this should not generate waste, and so that our products should be such which may have a longer life. So this is the key principle for this. And then keep products and material in use as much as possible. Similarly, regenerate natural system. That soil health is deteriorating, and our agriculture is also facing a lot of problem. And in such condition, if these organic waste are used in agriculture field, certainly the soil health will be improved. So in such condition, this circular economy has to be promoted. And this reduces the pressure on landfill, on ocean and ecosystem, and reducing emission and energy consumption. So this is the outcome of this circular economy. And you know that we have a very good example. We can, this circular economy offers industrial symbiosis. Waste of one industry becomes a raw material for another industry. So this is the, so nothing is waste. There is a zero waste policy, and waste is only displaced resource. As I said, there is a symbiotic relationship between industry, and one industry waste is raw material for another industry. And we have a very good example here, and we have a very good speaker who has worked very well on this field. So my suggestion will be that we have to be sincere for this circular economy. And initiative has been taken at grassroots level. And there is a good example of Bhopal's e-clinic model. And this model offers a partnership between a local NGO and municipal corporations. And there was a successful demonstration of this model where one NGO, that's Sarthak Foundation, and Municipal Corporation of Bhopal, they have developed a kind of e-waste clinic to address all such problem. And this model became the part of life mission, and it was also a part of that our proposal in COP30. So with this, I like to introduce you with the dignitaries sitting here in the dais. We have Sri Sanjeev Kumar Singh ji. He is Chairman and Managing Director of Hindustan Copper Limited. And you know that copper is a very difficult metal, because whatever waste is generated in copper industry, it is highly toxic. Addressing this metal is a very, very difficult task. And I know personally, this Hindustan Copper did a very good work in this field, and they have done extremely good. They have developed good technology, and effectively they have addressed the problem of copper waste. And copper waste, there are two types of waste, you can say. One is overburden, and second is tailing. So these two types of waste are effectively dealt by Hindustan Copper Limited, and will request Sri Sanjeev Kumar Singh ji to tell about this. And he is having about 38 years of distinguished experience in mining, planning, and design, and he has served in key positions across India's major public sector mining organizations. His tenure at CMPDIL and NTPC, along with international engagement in Indonesia and Australia, reflects his global perspective and technical depth. Under his leadership, Hindustan Copper Limited is poised for strategic expansion, operational excellence, and renewed national contribution. Similarly, we have a speaker, Sri Ashish Panpalia ji. He is cluster head in Ultratech Cement. And I know personally, this Ultratech did a good job of addressing plastic pollution. They have used this plastic as fuel in cement industry, and a successful model they have developed. That's why this IISF has invited Ashish ji and Sanjeev Kumar ji here to share their experience of addressing this kind of waste. This our Ashish ji, leading major units such as Aditya Raman and Hirmi Cement Works, to managing key functional roles at Gujarat, Awarpur, and Ridi Palayam, reflects deep operational expertise and strategic insight. Throughout his tenure, Sri Panpalia ji has demonstrated a strong commitment to efficiency, safety, and innovation. His contribution continue to strengthen Ultratech Cement's position as a leader in the Indian cement manufacturing sector. You all are aware that is a leading industry in cement, and Ultratech did a commendable work in this sector. And I also, on behalf of IISF organizing team and my own behalf, I welcome these two speakers, and I request them to please share your experience with the audience. Thank you very much.
Thank you, Dr. Shukla ji. So now I request Sri Sanjeev Kumar Singh to deliver his keynote address. Please, sir.
थैंक यू डॉक्टर लक्ष्मण कुमार जी। सभी को मेरा सादर नमस्कार। परम आदरणीय डॉक्टर एनपी शुक्ला साहब, अल्ट्राटेक से डॉक्टर मिस्टर आशीष, प्रोफेसर संजीव गौतम जी ऑन द डैश, ऑफ द डैश डॉक्टर मिश्रा जो धनबाद से आए हुए हैं, डॉक्टर अंकित और सभी लोग एकेडमी से जो रिसर्च एक्टिविटी से जो जुड़े हुए, पीछे जो कुछ विद्यार्थी दिख रहे हैं, बच्चे दिख रहे हैं, सभी को मेरा सादर नमस्कार। In fact, I should say it is an honor and privilege for me in the capacity of CMD Hindustan Copper to address this learned gathering at the India International Science Festival 2025. And I extend my sincere appreciation to the Ministry of Earth Sciences, Indian Institute of Tropical Meteorology, and our esteemed partner institutions for orchestrating this magnificent celebrations of science, innovation, national advancement, and for providing a forum for ideas to flourish and collaborations to flourish. Sir, ये जो theme है, the theme of this festival, विज्ञान से समृद्धि for आत्मनिर्भर भारत. This is in the heart of each and every Hindustan Copper's employee. हमारे जो आदरणीय प्रधानमंत्री जी की जो विकसित भारत 2047 की जो मनोकामना है, उसको हम लोगों ने अपने बॉडी में इनवाइट किया है. And this is how Hindustan Copper is going to contribute to the nations. And SCL is uniquely positioned at the confluence of science, technology, industry, and sustainability. मैं just कॉपर के बारे में आपको बताता हूँ. कॉपर एक शाश्वत धातु है सर, कभी ना खत्म होने वाला मटेरियल है, और इस चीज को हमारे ऋषि मुनि 10,000 साल पहले से जानते थे. ये जो आज कॉपर है, जो कॉपर की उपयोगिता हम सभी जानते हैं, इलेक्ट्रिक व्हीकल्स, विंड मिल्स, जितने इंफ्रास्ट्रक्चर डेवलपमेंट है, सारी चीजें. बट आपको पता है अभी सबसे ज्यादा कंज्यूमर, सबसे ज्यादा यूसेज कॉपर का आर्टिफिशियल इंटेलिजेंस में. Suddenly this has grown up, and the Bhagwan, God has not been kind enough, not only for India, in fact for Bharat, we have got only 0.2% of the reserves of the whole globe. In fact, if you see, the mines across the globe are going deep, the grade is decreasing. और मैं ग्रेड इसलिए बोल रहा हूं बार बार क्योंकि आज अभी आपने जो टेलिंग्स और वेस्ट के बारे में बताना है, उसका ग्रेड से एक सीधा संबंध है. हम सब उसी इंडस्ट्री में काम करते हैं और शाश्वत और इनफैक्ट हम हिंदुस्तान कॉपर में इसको डिवाइन मेटल बोलते हैं। उसका कारण है जब आप सुबह सो के उठते हैं तो आप सोचिए आप तांबे के लोटे में सूर्य भगवान को अर्घ्य देते हैं और मंत्र पढ़ते हैं। आप तो ईश्वर से सुबह से ही जुड़ गए। और जब शाम को आप सोने जाते हैं तो जो आप घंटी बजाते हैं उसमें भी कॉपर का योगदान रहता है। तो जस्ट सी हाउ क्लोजली ईच एंड एवरी इंडिविजुअल इज कनेक्टेड टू गॉड थ्रू कॉपर। माइंड इट, दिस इज वेरी इंपॉर्टेंट व्हाट आई एम सेइंग हियर। आप सभी लोग मोबाइल फोन लिए हैं, फोटोज खींच रहे हैं। आपको पता है इसका सिम कार्ड कॉपर का एंड व्हाई इट इज कॉपर? व्हाई नॉट एल्यूमिनियम, एनी चीपर थिंग? बिकॉज copper has got the potential to store millions of audio and visual data. किसी और के पास नहीं है। आप टेक्स्ट करते हैं, वीडियोस भेजते हैं, just through copper. See the importance of copper. और ये मैंने बोला अपने ऋषि मुनि 10,000 साल पहले जानते थे। You can Google it and see ऋषि यंत्र जो बनते थे उसमें बैटरी नहीं होती थी, वो अपने मंत्रों के उच्चारण से उसको इंसाइट करते थे। This is what is written there. But just see the concept and the strength of copper since last 10,000 years. It is the only material which you recycle remains, उसकी property, it remains 99.995 और किसी की नहीं है। इसीलिए इसको हम लोग रिसाइकिल करके यूज करते हैं सर। और दुनिया में आप कहीं भी चले जाइए, लैटिन अमेरिका में, वहाँ लेडीज दे डोंट वेयर गोल्ड एंड सिल्वर ज्वेलरी, दे वेयर कॉपर ज्वेलरी। पोस्ट कोविड वी ऑल हैव नोन द इम्पोर्टेंस ऑफ कॉपर। कॉपर क्यूब्स लोग घड़े में डालते थे और सब कॉपर के ग्लास में लोग पानी पीते हैं, जग पीते। तो दिस इज द इम्पोर्टेंस ऑफ कॉपर, आई जस्ट वांटेड टू से। पर दुर्भाग्यवश हमारे यहाँ जो रिजर्व्स हैं जिसको हिंदुस्तान कॉपर माइन करता है, दे आर ऑफ नाउ ग्रेट, घटता जा रहा है। आज से 30 साल पहले 1.3 था, बट नाउ वी आर माइनिंग एट 0.8। तो आप 0.8 का मतलब समझ रहे हैं, जब हम 1 टन माइन करते हैं 96% हमारा वेस्ट चला जाता है। नाउ द थिंग कम्स, लोग उसको वेस्ट बोलते हैं, बट एज अ माइनिंग इंजीनियर आई डोंट कॉल इट एज अ वेस्ट। जैसे शुक्ला साहब ने अभी कहा, नहीं, इसको एक दूसरी परिभाषा देनी होगी। 3 दिन पहले एक्स चीफ सेक्रेटरी मिस्टर DS मिश्रा ने बोला, नो मिस्टर सिंह, इट इज नॉट अ वेस्ट, ये आपके लिए रिसोर्स है। बिकॉज अभी हम उनको बता रहे थे कि साहब हमने एक वहां पर पेस्ट फिल प्लांट बनाया है। पेस्ट फिल प्लांट में क्या होता है, टेलिंग्स 90% टेलिंग्स आता है, 9% उसमें GBFS मिलाते हैं एज अ बाइंडर, 1% सीमेंट, और उसको नीचे जाके भर देते हैं वॉइड्स में, which not only takes care of my environment, of my tailing pond, but takes the strength और productivity और safety को बढ़ाता है। तो now see how this waste, जो आज से कुछ दिन पहले तक waste बोला जाता था, has suddenly become a big resource for Hindustan Copper. Overburden dumps, जो सर ने भाई भी बताया, overburden dumps का rock है, उसको हम crush करके we sell it in the local area of that Balaghat district. डॉक्टर शुक्ला से तो ज्यादा मुझसे बहुत ज्यादा वो एसोसिएटेड रहे हिंदुस्तान कॉपर से। आई टेल यू, आज जिस प्लेटफॉर्म से हम लोग दौड़ रहे हैं उन्हीं का बनाया हुआ है, एज फार एज एनवायरमेंट कंसर्न्स ऑफ मालांज खंड इज कंसर्न्ड। इनफैक्ट मैं उनको सादर नमन करता हूं सबके सामने कि उन्होंने जो हमें गाइडेंस दिया था उस समय, क्योंकि कॉपर जैसा उन्होंने बताया ना, टॉक्सिक होता है, पानी पड़ता कॉपर सल्फेट बन जाता है। तो यू हैव टू टेक केयर ऑफ दैट वाटर। आसपास विलेजेस हैं, with due care to them। और अभी भी जब मैं डायरेक्टर था या CMD था, I used to go to those villages sir। मैं सरपंच से मिलता था, उनको पूछता था। अभी हम लोग कुछ पानी का और वहां पे आया है कि और पानी आप करिए, हमने कहा नहीं साहब, पाइपलाइन भी लगा देते हैं, जबकि मध्य प्रदेश सरकार भी उसको कर रही है, लेकिन हम खुद भी करेंगे उसको। सो दिस इज द इंटेंट एंड स्पिरिट ऑफ हिंदुस्तान कॉपर। हो सकता है हम चूंकि एक सरकारी कंपनी, हमारे यहाँ स्टेप्स थोड़ा सा डिलेड होते हैं, बट देन जस्ट अप्रिशिएट आवर स्पिरिट एंड किस तरीके से हम उस चीज को एड्रेस करना चाहते हैं। तो ये सर हमारा जो सर्कुलर इकोनॉमी के ऊपर में वो था, उसके ऊपर, और हम 4 मिलियन से करीब 12 मिलियन टन एक्सपैंड करने जा रहे हैं, 3-fold एक्सपेंशन। तो हमारा सारा चीज 3-fold बढ़ेगा। मालंज खंड which is now producing roughly 2.8 million tons will go to 5 million tons. We are coming up with another paste fill plant. हम नहीं चाहते हैं कि हमारा वेस्ट जो है वो बाहर जाए, फिर बारिश हो, बिकॉज nowadays you just see how this environment has got deteriorated. इतनी रेनफॉल हो रही जो पहले नहीं होती थी। So with this exaggerated, extended monsoons, we are also having problems. So why to keep the waste outside? keep it inside the mother earth. और nature कभी waste नहीं बनाता. We as a miners, we destroy earth for our greed. Greed, I should call it as a greed because हम चाहते हैं, develop करना चाह रहे हैं, तेजी से भाग रहे हैं. Fifth economy है, सब fourth बनेंगे, third बनेंगे. And without this copper, I tell you, आपकी journey अधूरी है. In fact, journey क्या है? जो अयोध्या का राम मंदिर है साहब, जब वो बन रहा था तो बोला गया कि इसकी आयु क्या होगी, तो बोला गया कि साहब L&T इंजीनियर्स बोले 125 years, उससे ज्यादा. तो बोला नहीं, we need a temple of 1000 years. And their reply immediately came, then we need copper. और उस समय हमारे जो CMD साहब थे, अरुण शुक्ला साहब, उनको दिल्ली बुलाया गया और उनको बोला गया जो भी आपके पास बचा है आप बेच नहीं सकते, because my smelters and refineries were closed. So at that time we gave 32 tons of copper in the form of rod and strips, और वो हमारे अपनी धरती का कॉपर है. तो आप जब भी आप दर्शन करने जाएं राम मंदिर में, तो you can proudly feel आप ही के धरती का कॉपर लगा हुआ. साहब मलंजकन का है सर, शुक्ला साहब आप ही का है, सब किया हुआ. तो just see how strong copper is. मैं just आप लोगों को आज बताने आया था. And the अभी डॉक्टर मिश्रा देख रहे थे, कॉपर कंजम्पशन हमारा सिर्फ मात्र 0.5 to 0.6 kg पर पर्सन है. वर्ल्ड में 3.2 है और जर्मनी और अमेरिका में 17-18 kgs पर पर्सन. तो अभी वी हैव लॉन्ग, और 140 करोड़ की जनसंख्या है. आप सोचिए ना, जितने लोग बैठे हैं सबके पास दो मोबाइल है. वन मोबाइल हैज गॉट 30 to 70 grams ऑफ कॉपर. और मैं आपको बताऊं, अभी हमारे यहाँ, हमने आपको पहले ही बताया, हमारे पास सिर्फ 0.2% ऑफ द कॉपर, वर्ल्ड का कॉपर रिजर्व्स है. दैट टू वी आर आल्सो गोइंग डाउन, grades are depleting, all tough conditions are coming up at all three mining sites in Rajasthan, Malanjkhand and Ghatshila. The only good thing is that we have all reopened our mines in Ghatshila. ईश्वर अगर चाहेंगे तो इसका रिफ्लेक्शन आपको नेक्स्ट ईयर के प्रोडक्शंस में दिखेगा. बट सबसे बड़ी चीज है, देखिए साहब, कॉपर के साथ हम, चूंकि ग्रेड हमारा घट रहा, हमने पहले एक्सप्लेन किया आपको, लॉट ऑफ वेस्ट इज गेटिंग जनरेटेड. तो उस वेस्ट को हमको और कितना बढ़िया तरीके से हैंडल कर सकते हैं, इसके लिए हमने व्हाट वी डिड, वी हैड एन MOU विथ कोडेल्को, जो वर्ल्ड की सबसे बड़ी कॉपर की कंपनी है, विच प्रोड्यूसेस 200 million tons ऑफ ओर. कहां हम 4, कहां वो 200, जस्ट सी. बट दिस इज अ divine relationship. I again tell you, this is a divine relationship which I could do it because of the divinity part of copper. I worked in NTPC, I worked in Coal India. In NTPC, we could not take a block in Australia. Just see here, we could do it. It is all because of the divinity part of copper, I tell you. मैं अपने सभी लोगों को बोलता हूं, it is, we have to work. इसमें deviations के chances बहुत कम है. और अभी हमारी सभी mines तीनों जगह अंडरग्राउंड हो गई हैं. तो ओपन कास्ट का वो जो डिस्ट्रक्शन वाला पार्ट है वो खत्म हो गया है. वी ऑल हैव गॉन डाउन, एंड अंडरग्राउंड में वैसे भी सरफेस डिस्ट्रक्शन ना के बराबर होता है. इनफैक्ट आई टेल यू, वी हैव बीन डूइंग सम गुड थिंग्स आल्सो इन खेतरी. आप इकोनॉमी की बात कर रहे हैं, सर्कुलर इकोनॉमी की बात कर रहे हैं सर. हम लोगों ने वहां पे खेतरी म्यूनिसिपल कॉर्पोरेशन को अपना लैंड दिया, एंड दे हैव कंस्ट्रक्टेड अ प्लांट देयर. और वो जो उनका 1 MLD वाटर आएगा, दैट वी विल बी टेकिंग इट एट द प्राइस, जो भी गवर्नमेंट फिक्स करती है प्राइस. दिस विल स्टार्ट फ्रॉम दिसंबर और जनवरी, एंड वी विल transfer that water which we are using in the mines to my colonies, because my colonies and township get water every third day. Just see किस tough conditions में हम वहां काम करते हैं. तीसरे दिन पीने को पानी मिलता है. ठीक है साहब, लेकिन यही कॉपर हमको स्ट्रेंथ देता है काम करने का, और यहीं पर हम उस पानी को, जो पानी यूज करने के लायक नहीं है, वी विल बी यूटिलाइजिंग इट थ्रू दिस मोड. So ये कुछ चीजें थी जो आई थॉट कि बिफोर आई कम टू माय प्रेजेंटेशन आई शुड टेल अबाउट कॉपर, बिकॉज कॉपर सब लोग जानते हैं, डॉक्टर कॉपर उसको बोलते हैं बिकॉज ऑफ इकोनॉमी एंड ऑल दैट. और कैसे हम इससे अध्यात्म से जुड़ते हैं, कैसे हम भगवान से जुड़ते हैं, क्या हमारा रोल रहा है राम मंदिर में. तो ये हमारा एक बहुत ब्रीफ प्रेजेंटेशन है जो मैंने अभी आपको बताया. I will go into this very fast. This is how we were formed in 1967. Now we are quite old. It started from Khetri. We made a plant at Taloja. We opened a mine in 1982, Malanjkhand. That was the last biggest deposit which India has discovered. उसके बाद साहब आज तक कोई भी बड़ी deposit हम discover नहीं कर पाए हैं. And because of this, which Hindustan Copper went into an MOU with कोडेल्को, जो चिली की सबसे बड़ी कंपनी है, और ईश्वर अगर चाहेंगे तो एक आध महीने में आप सुनेंगे कि हम लोग कुछ ब्लॉक्स वहां पे ले रहे हैं. अभी सारा ड्यू डिलिजेंस चल रहा है. हमने एनडीए साइन किया, तो मैं इस फोरम से आपको कुछ बता नहीं सकता हूं, बट ईश्वर की कृपा रही तो वी शुड स्पीक समथिंग गुड पोस्ट दिसंबर. उसके बाद आप देखिए, हमने 2024 में एक बंद माइन थी जो 2001 जुलाई से, उसको हमने MDO मोड में दिया. दैट टू रेवेन्यू शेयरिंग. दिस इज द फर्स्ट रेवेन्यू शेयरिंग मोड मॉडल अडॉप्टेड बाय हिंदुस्तान कॉपर. और हमने सभी माइंस खोल दिया. लास्ट हमारी दिस अक्टूबर में खुली है केंदाडी, विच वी आर ट्राइंग आवर बेस्ट टू गेट द प्रोडक्शन इन लास्ट 3 to 4 months. ये हमारी जर्नी है. These are our sites. You can see 3 sites, one Khetri, Malanchkhand in the center of India. That is a flagship mine of Hindustan Copper. And these are on the right-hand corner. You can see the MOUs which we have done. So there is no dearth of money with Hindustan Copper now. Although we are a very small company, not cash rich, what we earn, we spend it in the expansion programs. But just see, CSIR के साथ हमारा है, राइट्स के साथ है, कोल इंडिया के साथ है, IOCL के साथ है, और हमने 3 दिन पहले NTPC माइनिंग के साथ भी किया है. They are with us to restart the smelters and refineries also. See the positive aspect of Hindustan Copper. ये हमारा ग्रेड है जो हम आपको दिखा रहे हैं, जिसकी वजह से हमारी टेलिंग्स का जनरेशन ज्यादा होता है. You can see in ICC, KCC and overall हम 0.85 के आसपास आ गए. Rather ये जब हम माइन करते हैं तो we are mining around 0.7. So just see how much tailings and waste we are generating. But I should not call it waste at this forum. This is a resource for backfilling for us. हम लोगों ने पिछले 3 साल में लगभग 140 tons कॉपर का रिजर्व्स और रिसोर्स ऐड किया है. We have made our company more valuable. This is how we have added. ये कुछ हमारे operations हैं. I have already mentioned कि हमारे सारे underground mining operations हैं. और सर जहां तक pollution वगैरह को कम करने की बात है, what we have started, we have promoted electric driven, that is battery operated machines in Malanchkhand. Same machines are being operated in some other mines. अभी trial पे है sir, but we will try to see that within 5 years, 30-31 तक हमारा जो net zero का targets है वो हो जाए, और वैसे भी हम 47 के पहले ही net zero achieve कर लेंगे. हम लोग सब जो plantation करते हैं ना, उसमें भी geotag करते हैं sir. This is also one of the important thing which we are doing. उससे हमें carbon footprints मिलने में बहुत सहूलियत होती है. This is what we started last year only. This is the importance of mine waste management. देखिए सब रिसोर्स से लेके उसके रिस्क मिटिगेशंस जो हमने अभी आपको बताया, उसका कैसे डिस्पोज ऑफ करते हैं. जैसे मलांचखंड का एग्जांपल मैंने दिया, बिकॉज बाकी दोनों तो अंडरग्राउंड माइंस हैं, ओवरबर्डन डंप होता नहीं है. बट एज फार एज टेलिंग्स आर देयर, वी पुट दोस टेलिंग्स बैक इनटू द मदर अर्थ. उसके 2 फायदे हैं, एनवायरमेंट, cost efficiency and sustainability, because now sustainable mining has become more important. We all know about ESG sir. If you don't protect environment, if you are not sustainable, if you are not doing your business properly, governance अच्छा नहीं है, so nobody is going to give you a 1 rupee loan also. So communities के साथ हमको चलना है. We have to take their trust and support, and on this I like to tell you, whenever I visit a mine, I go to वहाँ के आसपास के जो सरपंच वगैरह हैं, उनके परिवार के साथ मैं बैठता हूँ, इधर सुबह और शाम को उनके साथ उनकी समस्याओं, बिकॉज वो वहां से जुड़े हुए हैं. हम आप तो एयर कंडीशन रूम्स में बैठते हैं. दे आर द पीपल हु सिट देयर, उनकी जमीन पे माइनिंग कर रहे हैं, तो उनकी एक्टिविटीज, उनकी जो जरूरतें हैं उसको पूरा करना हमारा कर्तव्य भी है. तभी ये सर्कुलर इकोनॉमी भी पूरी होगी सर. इनोवेशंस, हमने इनोवेशंस के बारे में बताया. एक बहुत बढ़िया इनोवेशन हमने किया जो मैं शेयर करना चाहता हूँ. खेतरी की माइन से 400 मीटर के नीचे से हमने व्हाट्सएप वीडियो कॉल किया है, एंड दैट टू विद द कोलैबोरेशन और विद द C.DOT और BSNL जो हमारी गवर्नमेंट की बॉडीज है. जस्ट सी, 6-8 महीने लगा. दैट वाज एन R&D प्रोजेक्ट, बट वी कुड डू इट, एंड नाउ वी आर गोइंग टू डू इट कमर्शियली. दैट इज ऑल्सो गोइंग टू हेल्प अस इन दिस ग्रोथ ऑल्सो सर. ये कुछ स्टैट्यूटरी रिक्वायरमेंट्स भी हैं गवर्नमेंट ऑफ इंडिया से. इनफैक्ट पिछले 10 साल में जो हमारी सरकारें रही हैं, नॉट ओनली दे हैव ईज्ड डूइंग बिजनेस, बट उन्होंने कुछ ऐसे हमको नियम भी उसमें और बताएं जिससे कि हम अपने वेस्ट को मतलब इन अ प्रॉपर साइंटिफिक वे आई शुड से वी हैव बीन यूजिंग इट एंड उसको रिस्टोर करके रिहेबिलिटेट करके एंड वी आर ट्राइंग टू ब्रिंग इट एज फार एज पॉसिबल टू द ओरिजिनल लैंडस्केप जब हमको पहले वो लैंड मिला था. एंड नाउ द गवर्नमेंट इज ऑल्सो वेरी सीरियस ऑन इट. ऐसा नहीं है कि आप इन सब चीजों से बच जाएंगे. So this is the role of stakeholders in waste management. Government, which is a regulatory body, mining company hum, which what I have said, we implemented, and local communities. See, because उनका role बहुत ज़्यादा है. ये waste या tailings या ash या जो भी है, उनके अगर किसी use में आता है, तो it should be given to them. और अगर इससे कुछ toxic elements generate होता है पानी में या कहीं पे, तो उसका take care करना is our duty. And how this is how we have been doing there. And we will be doing much more on that, in fact, as far as water is concerned. Embracing circular economy principles in mining. ये वही है सर जो आपने just brief में बोला था. How to identify mining में तो it has been already identified. And how effective we can generate. We should generate as less as possible. See, optimization of mine planning and all that comes into picture. जहां तक आपकी बॉडी एक्सटेंड हो रही है और बॉडी बस वहीं तक माइनिंग करिए. डोंट गो बियॉन्ड दैट, सो यू विल बी जनरेटिंग लेस वेस्ट. सो दिस इज वेयर टेक्नोलॉजी एंड माइंड प्लानिंग कम्स इनटू पिक्चर. फिर उसका क्या पर्पस है? इनफैक्ट यूज इट इन सच अ वे दैट इट नेवर गेट्स वेस्टेड. नोबडी शुड कॉल इट एज अ वेस्ट. रिसाइकिल अगेन, अपसाइक्लिंग करिए उसका. मतलब जैसे हमारे टेलिंग डैम्स में देयर इज लॉट ऑफ वाटर. वी हिंदी में जैसे हम कहते हैं ना, उसका सारा पानी हम निचोड़ लेते हैं. सारा पानी टेलिंग डैम से हम निचोड़ लेते हैं. एंड दैट इज द इंडस्ट्रियल वाटर व्हिच वी यूज इट फॉर आवरसेल्व्स बैक टू द बेनिफिशिएशन प्लांट वेयर वी हैड बीन यूजिंग दिस वाटर. आई विल शो इट टू यू व्हाट वी आर डूइंग देयर. सो अब ये देखिए वेस्ट जनरेशन, वेस्ट रॉक, टेलिंग्स. आप देखिए फिगर्स में आइए जो टोटल हिंदुस्तान कॉपर करता है, और उसमें से इतना वाटर हम ये करते हैं. मालांश खंड देखिए 60% ऑफ टेलिंग जनरेटेड जो मैंने बताया पेस्ट, एंड जीरो लिक्विड डिस्चार्ज सिस्टम इज फंक्शनिंग प्रॉपर्ली. वो सर आप ही के समय का बनाया हुआ था जो जीरो लिक्विड डिस्चार्ज हम लोग अभी कर रहे हैं सर. और हम लोग इसलिए ये सारी चीजें आपकी ही की हुई हैं. ओनली थिंग इज दैट वी आर फॉलोइंग इट इन अ प्रॉपर वे. बस यही मैं प्रार्थना करता हूँ, वी शुड नॉट डेविएट फ्रॉम दिस. So these are the initiatives of Hindustan Copper. I mentioned that mine waste rock जो हम करते हैं, we sell it. This is the revenue which we have generated ourselves. 91 lakh is the royalty and taxes which we have given to Madhya Pradesh government. About mine tailings I've mentioned, and the same things we are doing in Jharkhand mines also. I've already explained this. 90% tailings, 9% GBFS, and 1% cement. This is the binder which gives us the strength there. And within 15 to 18 days, this void, which when filled with this, gains strength of more than 28 megapascals, sir. This is what I wanted to show you. Dr. Shukla ke interest ki cheeze unhone. This is, see how we are managing our zero liquid discharge system. And this is mine, हमारा tailing dam hai. Then you see the beneficiation processing plant where we consume lot of water. And then effectively we are maintaining this. And this is, with these efforts, Malanj Khand has achieved a 48% water recycling efficiency within the concentrator plant. We are saving water there also. In fact, we are trying with NML Jamshedpur to take our concentrate and do a pilot project for us of dry concentrations. Dry. We use water here. We have given them the money also. कि आप experiment करिए. Just see if this can be replaced with a जैसे coal में dry deshelling, whether we can do this or not. तो अगर ये successful होता है तो फिर then this will again add to us कि और पानी की बचत होगी हमारी. This is जो मैं बता रहा था, नीचे ये स्टोव है. देखिए कैसे ऊपर से हम भरते हैं. Just see, ये जो black वाला portion इस surface तक जाता है और ये solid cube बन जाता है आपका वहाँ पे. So this, just see how the जो हम कल तक waste बोल रहे थे, how this has become a resource for Hindustan Copper. ये हमारा पेस्टल प्लांट है, ये हमने गोल्डर्स एसोसिएट्स कनाडा के कंसल्टेंसी से बनाया है, एंड दिस वाज कंप्लीटेड इन अ रिकॉर्ड टाइम ऑफ 20 मंथ्स, शेड्यूल टाइम 4 मंथ्स का था, बट सापोर जी पालुन जी वेर आवर पार्टनर्स executors who did this job in a record time of 20 months. These are the top views. And this is, see, सर ये डंप है सर आपके समय का ओवरबर्डन डंप जो हमने इस तरह से रिक्लेम किया है, और इसको हम ड्रोन से लेकर के एवरी क्वार्टरली वी टेक अ पिक्चर ऑफ दिस सर, और वी कीप इट. ये जो टेलिंग डैम है उसमें जो हमने पिचिंग की है पत्थर से सर, सो दैट कि लीकेज कम से कम हो. हम चाहते हैं पूरा डैम हो जाए, पर ये थोड़ा सा 2 साल का प्रोजेक्ट है. विल डू इट सर. So this was a brief presentation which I made with reference to Hindustan Copper, but I'm thankful again to the organizers who gave me the opportunity to come down to Chandigarh and speak in front of you how copper is important to the nation, और ये आत्मनिर्भर भारत की तरफ बढ़ने के लिए कॉपर एक बहुत ही इंपॉर्टेंट चीज है. इसमें एक लास्ट पॉइंट बता दूं, अभी आप सब लोगों ने सुना होगा, गूगल is going to develop a data center in Vizag. That will be the biggest data center outside USA, and the investment is $15 billion and 65,000 tons of copper, sir. सोचिए सब, क्या कॉपर में शक्ति है इस देश को आगे बढ़ाने के लिए. हम तो आगे बढ़ ही रहे हैं, हम 1% जो भी कर रहे हैं इस देश के लिए और उसके लिए जा रहा है. और लेकिन हमारा, हम जैसे पहले कहे, कॉपर एक शाश्वत धातु है, कभी नहीं खत्म होने वाला. जब तक राम मंदिर रहेगा, हिंदुस्तान कॉपर का नाम भी रहेगा. जय हिंद, जय भारत, धन्यवाद.
Thank you, sir. Hello. Thank you, sir, for delivering the illustrative talk. Now I request Shri Ashish Panpalia ji, Cluster Head, Ultratech Cement, to deliver his keynote address. Welcome, sir.
Good evening, everyone. So, dais pe Dr. N.P. Shukla, Mr. Sanjay Kumar Singh, and the person who was coordinating with me, Mr. Sujit and Dr. Shukla, Mr. Arvind Kumar Mishra. So, I feel fortunate to represent Ultratech Cement here on this forum. I'll be taking you to the presentation on alternate fuels and what we are doing at Ultratech. And today I will be sharing our journey, achievements, challenges, and the future plans what we have at Ultratech Cement. So, Mr. Sanjeev, I just wanted to say that कि इन्होंने जो बताया था राम मंदिर में कॉपर लगा है, तो मैं एक चीज और बताना चाहता हूँ कि राम मंदिर में अल्ट्राटेक सीमेंट भी थोड़ा सा यूज किया गया है. सो आई विश कि आपके कॉपर की जितनी लाइफ वो भी दे पाए वहां पे. थैंक यू सर. So what the contents which we'll be covering here is AFR uses as Ultratech, and second, our infrastructure, what we have developed over the years in Ultratech, and the key issues which we are facing in this domain, and finally our future plans. So if you could see that the alternate fuel system which has been installed in approximately, we have pan India, we have around 62 kilns that is producing cement, and out of that around 16 kilns we have installed the alternate fuel system, which these kilns can utilize it. And we have a capacity to consume almost 3 million tons of waste annually. We can pre-process, co-process a wide range of waste, that is solid, liquid, plastic, biomass, and hazardous industrial waste also. And our facilities include the testing platforms are also there. We have state-of-art laboratories setup is there, and co-processing systems also there. And not to tell that there are various rules, guidelines. These are already there for uses, handling, storage, and OHS, which has been used by regulatory authorities, and we are following them. So the AFR journey, if you see at Ultratech, this is a chart we are showing here, may not be visible clearly, but I will just explain that. It began in 2004 in our plant with the use of non-hazardous waste at our plant in Tamil Nadu at Reddypalayam Cement Works. In 2005-2006, we started hazardous waste trial at our Rashri Cement, which is in Gulbarga, and then Reddypalayam again in Tamil Nadu. In 2007, we established a MSW, that is Municipal Solid Waste Pre-Processing Facility at Jaipur in Rajasthan. In 2008, into co-processing unit was started at Vikram Cement Core, again under the direction of Dr. Shukla. In 2011 and 12, if you see, we installed a liquid waste feeding system at Andhra Pradesh, our works, cement works, and Gujarat cement works, because we have a lot of pharmaceutical and chemical plants available there. The waste generated, liquid waste generated from there, we installed these systems there for uses in our kiln. Over the years, we have added around 20 to 45, 45 TPH shredders, because you need shredders when you are using this segregated plastic waste or MSW waste, which we call it as RDF, to shred that into a small pieces which can be used for as a fuel, as a replacement of coal. If you see the last year, by 2026, we will be having a AFR system, this uses system in 22 of our kilns, with a co-processing capability of around 4.5 million tons of waste annually. These are our plans. So another, say, 6 months, we'll be having this capability. So types of waste. So we used a variety of industrial waste, which includes such as waste from automobile, then chemical. So automobile, you get a lot of paint sludge, oily cotton waste, and then from chemical industries, organic solvent, distillation residues, then ETP sludge from textile, pharmaceutical tablets, solvents, batch products, footwear, FMCG, those are the expired FMCG products, and the paper from recycling. So the key components of all this is the segregated combustible fraction from municipal solid waste. So we have a standard approach for uses of how we use this waste, because it cannot be just taken from the storage or the dump and cannot be used as it is in the system. So we have an expert assessment before we visit the dumps and analyze that, and then you have to take a permission from pollution control boards for the uses of this. So, and the regulatory clearances, then the MOUs with the municipal authorities, all this is being done in the first step. Then when the material is received, the laboratory control, the setup is there. It has to ensure that the proper receipts, sampling, and pre-processing has to be done for of this waste which has been received for co-processing. Then once you do the co-processing, then to complete the cycle, you have to ensure that the compliance and the what you call as a certification. So whoever agencies or the plants from where you are consuming the waste, you have to give the certification that it has been used in our plant to close the cycle. So let us look at the AF consumption over the years. So in FY20, we did close to 4 lakh 40 in the kiln, 4 lakh 40,000 tons of AF waste consumed. And if you see that by FY25, in FY25, we consumed almost 15.30 lakhs of AFR. And we have plans to scale it up to 40 lakh tons of uses. Similarly, in our thermal power plants, we are using some AFR, that is agro waste, pellets, and even the dolochar, which is the waste from the industry. So FY20, we did almost 45,000 tons of waste consumed in the thermal power plant. And we FY25 around 4.95 lakhs, and we have a plan to consume it to take it up to 6 lakh tons. So the coal saved, if you look at these figures, what these figures means, so we saved almost close to, by FY25 lakh 28,000 tons of coal, and in thermal power plant almost close to 2.90 lakh tons of coal has been saved. And the plan scaling up, you can see the plan which we want to by FY27. It is estimated that we'll be saving approximately 13.82 lakh tons of coal in the kiln. So if you convert that into CO2 emissions, almost I can say that in financial year 25, our CO2 reduction reached almost close to 18.16 lakh tons. And if you see in both kiln and TPP combined, almost per ton, the clinker which we are producing from in the cement plant. So in FY25, it was close to almost 22.6 kg per ton of clinker we saved on the CO2 consumption. So if you see the CO2 footprint, for every ton of clinker what we are producing at Ultratech, the CO2 is almost around 546 kg per ton of clinker. So it was 3 years back, it was around 630, 640 kg per ton of clinker, but our footprint has been reduced to 540 around. So if we see the regulatory framework for uses of this type of AFR, this includes the Hazardous and Other Industrial Waste Management Rule 2016, Plastic Management Rule 2016, Solid Waste Management Rules 2016, and guidelines also has been released for pre-processing and co-processing in cement plants 2017. So we are grateful to the regulatory authorities for framing and releasing these essential rules and guidelines, which enables the uses of this waste in our kilns. These guidelines not only ensures the safety, but how to handle and in the pre-processing, how to handle this waste. But these are necessary for environmental protection, legal accountability, and transparency and traceability of the waste which is generated and where it is getting consumed. So if we come to the infrastructure, what are the infrastructure, how we are doing that? So if you see, the special infra is needed at cement plants to store, convert, and different waste streams to an acceptable and uniform fuel for using in the system. So if you look at the picture, we have the almost for storage, most of the plants, we have minimum 10,000 meters square of covered shed. Then you have uh, the fire detection system, then the oscillating intelligent cameras to detect any smoke or the fire. Then the specific PPs are being used, personal protective equipments, for the people who are doing, who are on the job, their periodic health checkup. Then you need the restroom, toilet separately, because once the people are doing, when the people are doing their job, they may need to sometimes take the bath before they go out from that place. So all this infrastructure, the shredder, these are some of the picture how we are shredding and feeding the material. So if you see, we have a specialized feeding system for solid bed. So these are all, there is a pit here where the shredded material is being dumped into that, and there is a grab which takes the material, the shredded plastic, and feeds it into the hopper. For stable feed rate, you need the capability to blend it, handle it, because it's a very low density material. And the central control, also most of this thing is done centrally, though a lot of operations are manual. But once the shredding and once the material comes into the pit, everything is controlled from the central control room. So we have a well-equipped laboratory and for testing of this waste. So if you see some of the equipments here, just I wanted to highlight. We have the gas chromatography. The purpose is to separate and identify complex mixtures of hazardous waste components. That is VOCs, volatile organic compounds, pesticides, and industrial pollutants. Then we have GCFID, which is gas chromatography, which identifies the organic compounds, especially hydrocarbons, in hazardous waste samples. Then we have GCECD, which is electron capture detector, which detects and quantifies halogenated compounds, pesticides, and aromatic pollutants in hazardous waste. So apart from that, we have wet chemical analysis, flashpoint, KF titrator for detecting the chlorides. Apart from the basic equipment, we have the bomb calorimeter to understand what the energy values it comes from that use of that AFR. So we have a CHNSO analyzer. So these laboratories are totally, we have around every plant where we are using laboratory. This kind of equipments are always available, because without this testing, you cannot use the AFR system in your plant. So waste loading and transportation, if you see the compliance as the guidelines issued by the regulatory authorities, you need to have a special notified vehicles for use of this. And the loading, transportation, unloading, everything has to be notified, and only dedicated vehicles are being used for this transportation. So these are some of the pre-processing pictures where we are, once the waste arrives, how we are pre-processing and then blending it into the system. So once the heap is there, so you have to, different MSW, different RDF has different calorific value and different contents. So you have to blend it, test it, and then make a proper heap for using into our system. So this is just a dump which is being the shredded material. So here, if you see that a lot of MSW, before this I wanted to just say that when you are getting the raw MSW from the sources, when it is coming to the plant and there are the storage facilities there in the shed, so a lot of bad smell, foul smell is there. So we use a lot of bioenzymes, and that blends naturally with this material naturally, and they have a breakdown that organic matter responsible for odors. And so the bad smell, we are at least in 90% we can avoid the bad smell which is generated, foul smell in that area. So these are some of the material where we are shading this left side. If you see the picture, which is the waste, the different kind of waste, and then we are shading it and making a homogeneous mix on the right hand side. So these are the picture of some of the this is picture from our Gujarat plant where we are getting this pharmaceutical waste solvents, and we have a special liquid firing system. And the tank here, right hand side, if you see the tank, it's a very hazardous liquid is being stored in that, and you have a nitrogen clouding, nitrogen system is there, where it creates a cloud on the top of the tank so that it doesn't come in contact with oxygen or any other, so because it's highly flammable. So this is just safety measures which are there in our plants. So key issues and actions, if you see the, as I said earlier, so you need a proper equipments and then the testing in the laboratory to create a proper blending of the material with the proper laboratory control has to be there. So this is one of the slide which I wanted to just share. So if you see the conventional fuels, the coal and the pet coke, the CV of the coal is around 6,300 kilocalorie per kg. The pet coke is around 8,000, and the MSW plastics what we are getting is around segregated. This is again I am telling segregated 1,200 to 3,200 CV is there. The moisture what we use in our system for the coal to burn is around 0.5 to 1% in coal. Pet coke is less than 0.01. MSW we get a moisture of around 30 to 50%. Ash also, if you see in MSW, it is around 20 to 45% ash is there. There are chlorides also present in the MSW. And the granulometry, we are coal and the pet coke we are grinding less than 2% on 90 micron. The coal we are less than 12%, but MSW and plastic, so it is 90 to 120 mm size is there. So 90% is less than 90 mm. So that's why that is the size minimum we want when you are using that material. So for that we have shredders and other facilities available. So if you see the slide, some of the plastics we are getting entangled with the wire, because there is a process when the paper recycling industries, when they remove the plastic, they wrap it up in a wire. So those material comes as it is to us, waste material comes. So we have a manual interventions to remove that wire before putting it in the shredder for uses. Then along with the MSW comes the stones, sand and metals, which when you are putting this material as it is, it damages the shredder. So we have some of the systems installed like ballistic separators, which removes the stones. Then trommel is there, which removes the dust particles from this material. Wind shifters and magnetic separators, wind shifters again to remove the to remove the plastic away from the dirt, and magnetic separators to remove the metals. So there are issues, but we have the solution. We have come out with some of the solutions which we are using. And then the big size cloth is also coming in that to overcome. We have, again, the ballistic separator and manual arrangements we are doing to separate it out. Then again, as I said earlier, the order due to waste, to address that, we are using some of the enzymes which degrades this order, the bacteria which they degrade this order. So wear and tear, so again the same thing, ballistic separator. So chloride is one of the thing which has a negative effect on our process, and it creates, if it settles on the kiln surfaces or in the preheater zone, calcining zone, it creates the coating. So through laboratory control, we ensure that the daily mass balance is being done in the system for regularly monitoring the input. So if suppose some material is having high chloride content, and so we try to see that it is blend properly in a with a mix to ensure that the permissible amount of material which is being fed contains a permissible amount of chloride, I mean to say. So sometimes along with this waste comes the dead birds, animals, and clinical waste also are there. So we are trying to see that we educate the MSW site operators to control all these things at the source. So in spite of our persistent efforts to address these issues, still there are problems, and this can be addressed more efficiently by source segregation and collection mechanism by municipalities. Uh, so source segregation is one of the area, like we are now moving into some of the places we are installing. We are working with some operators to install a pre-processing facility outside the plant near the source, so that all these things which we are removing in the plant, it is removed at the source only and gets completed as so that there are less nuisance to be handled in the plant. So these are some of our investment. Up close to 90 crores is required for a to set up a 1000 TPD co-processing plant. So till now we have spent around 1200 crores in AFR system in the Ultratech. So our future plan is to increase AFR infrastructure to 50% of its skills and capacity to co-process 7 million tons of waste annually. So thank you very much for your nice hearing. And let me tell you, let me reiterate that Ultratech Cement under Aditya Birla Group is united by shared vision of this forum to harness the power of science and technology for the prosperity and self-reliance of our nation. Thank you. Thank you very much.
Yeah, thank you, Ashish ji, for delivering the keynote address. So now we have come to end of the plenary session. That is the first half of this session. We will quickly felicitate our chief guests for this plenary session. So I request Dr. N.P. Shukla ji to felicitate our chief guest, Dr. Sri Sanjeev Kumar Singh, with a memento. I request our team to bring the memento. I request Shuklaji again to present the memento to our other chief guest, Shri Ashish Panpalaya ji. So I request again Shri Shuklaji to present the memento to Professor Sanjeev Gautam, Punjab University. So now I request Sanjeev Kumar Singh ji to present the memento to our Shukla ji. So delegates can have informal discussion after the entire session is over. That is around 6:15. All the speakers will be available. You can have an informal session. I request all the delegates to stay back and focus on the next half of the talk, half of the session. So I request the chief guest of now to sit in the audience and. So now we will have panel discussion. So now I request the chairman of the panel session, Professor Arvind Kumar Mishra, to come out to the dais. So before that, I request Adarsh Palji to come to the dais and welcome Professor Arvind Mishra with a bouquet. So I request Adarsh Palji to welcome Professor Arvind Mishra ji with a bouquet. I request panelists Dr. Manoranjan Mohanty to come, Waste to Wealth Mission to come out to the dais. So again, I request Adarsh Palji to welcome Dr. Manoranjan Mohanty with a bouquet, flower bouquet. So I request Mr. Satish Pandey, scientist, Central Road Research Institute, to come out to the dais. So again, I request Adarsh Palji to welcome Dr. Satish Pandey with a flower bouquet. So now I request Dr. Sujit Maji, Indian Institute of Tropical Meteorology, to come out to the dais and introduce the panel chairman as well as the panelists of this panel discussion. Sujit.
Good evening all. So it is a privilege to introduce Professor Arvind Kumar Mishra. He is director of CSIR CIFMR and a leading figure in mining technology. He is a profiling researcher with 200 plus publications. His work has significantly advanced explosives engineering and sustainable mining practices. His leadership and global collaborations have strengthened India's position in mining innovation. And next, it is my honor to welcome Dr. Manoranjan Mohanty. He is chairperson of the Government of India's Waste to Wealth Mission. He is a distinguished soil scientist with a PhD from University of Queensland with decades of impactful contribution to sustainable agriculture and environmental systems. Under his leadership, the Waste to Wealth mission has accelerated innovative technologies and models aimed at innovative and achieving a zero landfill, zero waste India. Today, we are privileged to hear his insights on transforming waste to valuable resources for a more sustainable future. Next, Mr. Satish Pandey. It is my honor to recognize Dr. Satish Pandey. He is a senior principal scientist and head of the Flexible Pavement Division at CSIR CRRI, whose pioneering work is in transforming India's road construction landscape. With nearly 2 decades of research experience, he has developed breakthrough technologies such as steel slag roads, EcoFix, RejuPave, Treasure Facing, MSS Plus, and several innovative cold mix and preventive maintenance solutions. Honored with prestigious awards including the Road Tech Awards 2025, Global Slag Personality of the Year 2023, and the CSIR Technology Award, he continues to set new benchmark in green and carbon neutral road engineering. It is my privilege to welcome Professor Adarsh Palvig. He is former chairperson of the Punjab Pollution Control Board and a senior professor at the Guru Nanak University. Over 30 years of distinguished academic and research experience. He is a leading expert in vermi technology, solid waste management, and earthworm biodiversity. He has guided 16 research scholars and contributed extensively through 103 journal publications, 10 conference papers, and 17 book chapters. It is my privilege to welcome all panel members to the panel discussion. Thank you.
Thank you, Dr. Sujit ji. Thank you very much. Esteemed dignitaries, distinguished panelists, respected colleagues, students, scholars, ladies and gentlemen. A very pleasant good evening to all of you. It is my privilege and honor to welcome you to this important panel discussion on circular economy, waste to wealth, at the India International Science Festival 2025 at Panchkula. At a time when our nation is marching towards Viksit Bharat at 2047, this theme is not only timely, but absolutely central to our developmental trajectory. Today, the world stands at a critical juncture. The traditional linear model of economy, take, make, and dispose, is no longer sustainable. With mounting resource constraints, rising waste generation, there is urgent need to decarbonization of economy. Circular economy offers a transformative pathway, one that converts challenges into opportunities and waste into wealth. India, with its vast scientific talent, strong innovation ecosystem, and scale of operation, is uniquely positioned to lead this global transformation. Our government's emphasis on resource efficiency, extended producer responsibility, green technologies, and sustainable mining and manufacturing opens unprecedented avenues for collaborative projects, collaborative R&D, collaborative S&T across research institutions, academia, industry, startups. In this context, our panel today brings together some of the most distinguished experts and practitioners in the field. I am certain that their insights will help us reimagine waste management, valorization of the industrial and municipal waste, deployment of advanced recycling technologies, creation of circular value chains that are economically viable, environmentally sound, and socially inclusive. I would encourage a vibrant, constructive, and forward-looking dialogue. Let us explore not just what is possible, but what is achievable, how science and technology policy, industry, and research can accelerate India's journey from a linear economy to a true circular and regenerative economy. I once again welcome all the panelists and participants to this exciting panel discussion. We do have three distinguished panelists with us. Dr. Manoranjan Mohanty, who is Director of Indian Institute of Soil Sciences, soil being the most important resource. I would like to have in his views on circular economy. Dr. Mohanty, please.
Thank you, sir. Good evening, everyone, distinguished chair and panelists. It's a privilege to be here and share my views on circular economy and in context of natural resource management. And my experience being the advisor 3 years at the Office of the Principal Scientific Advisor to Government of India and Mission Director West Coast Mission. So if I talk about the waste, how much waste India generated being generated in India, around 62 million tons every year. And to your surprise, I want to give you a data, ankda dena chahta hu. Only 70% are being collected. That means out of 60, if I say 70% means that 42 million tons are collected. From that, 30% are recycled. Again, if you consider the amount of waste that generated and amount that are actually recycled, then, and we have that the problems are plenty. Why I'm saying so, we are expecting around 160 million tons by 2030, but the way our economy is progressing, the way our industrialization is going on, so we are expecting more. That means looking at the data, then probably we are thinking of why so much of waste are being left behind and they are not collected. So good example is the segregation, because somebody in the plenary session talked about the segregation of waste. So Indore being the municipality being the great example for that. So they are doing around 7 to 9 types of segregation they do.
But if I say in general, if I can bring two segregation processes, one is biodegradable and another is non-biodegradable, then probably if I touch upon the biodegradable part, then probably go for composting, all those things, then utilize that for soil health. Because our previous plenary speaker, Mr. Suklaji, talked about that soil health. So being the director of that institute and looking at the soil health, um, paramount importance, Indian context, definitely yes. That part can be taken and can be used as manures, not only manures, can be used as waste to energy. That means from that biodegradable waste, we can go for bio-CNG production. From bio-CNG, if you go for, you can add other waste also, because we talk about paralis, all those things, burnings and crop residue, all those things. I'll come to that later on, bit maybe 2-3 minutes about that. So we can use that as energy as well as manures. Then coming to the non-biodegradable sources, definitely yes, there are many areas where technology plays important role for waste to energy production. When I was at office of the PS, being the mission director at that time, so we evaluated so many technology, particularly from waste to energy, from the non-biodegradable sources. Maybe different methodologies or technologies or techniques are available. Some of them energy consuming, just like be it pyrolysis, be it gasification. So these technologies, we need they're available. So we need to have some kind of technology that are affordable. So after the PSA as well as Mahua and Jal Jeevan Mission in Swachh Bharat Mission 2, when it look at the technological perspective for managing the waste, we have evaluated so many technologies for waste management sector. So, but that is not enough. In spite of that also, we could see still our legacy waste are lying there. And they not only pollute the environment actually, but they also create greenhouse gas emissions. Then what are the best possible way? When you talk about we want to make India net zero by 2070, and we have different plans for 2030 and 2047, where we want to see India the most progressive country or the developed country, then probably at that time we should think that our development is directly proportional to energy consumptions, and energy consumption also creating this kind of waste generation and then probably the greenhouse gas emissions. So technology plays important role in this sector, because it is estimated that waste has the capacity to reduce 25 to 30% of the greenhouse gas emissions. So managing waste and having a proper, a good technology also another options, because we have that power, we have that, I mean to say, we have the encouragement from the government as well as the policy. So if I look at the policy, then probably we have to think of some of those important areas like green credit or green bonds or the carbon credits. These are the three areas where actually we can see that through green credits, probably we can incentivize individuals or the farmers or the APOs to go for that, incentivizing them to go for some kind of plantation, saltwater harvesting, something like that to get the green credit. Probably look at the green bonds, probably the funding mechanism that can encourage us also. And look at the carbon credit, that is some kind of emission reduction process. So all those management, waste management and recycling of the waste, and use them in agriculture, also some kind of building and sequestering carbon in the agricultural soils, also one kind of carbon reduction process. The sequestration process gives you the carbon credit. So altogether, if I look at the policy perspective to the segregation to the management and participation from not only from the corporate sectors, also the companies as well as the startups, they are also very important in this whole process. And I want to share that, Malaj Khand, we have done some work with them actually from Indian Institute of Science and Bhopal. So HCL Hindustan Copper Limited, we had some kind of association in the past. We are looking forward to take that further, because some of the technology they need some kind of investment in research, and probably the corporate sectors or the private sector, they should come forward and help them, help the scientists, and to see that the technology that we are developing that helps us, that cost effective and innovative also. And one most important, Indian government also not only restrict themselves to the, inside India, through our one of the initiative, India European Union Trade and Technology Council, There also, you look forward to bring down, work with European Union in 3 areas of waste management sector, particularly battery recycling technologies, waste to hydrogen, and also in marine plastic litters. So 3 ministries, MNRE in waste to hydrogen, MOES in marine plastic litter, and MHI in battery recycling, that came forward and had good conversation as well as dialogue. And India had already invested so much on these 3 sectors with European Union to build technology and develop innovations for waste management sectors. So this is altogether in nutshell, I wanted to share with you the perspective of circular economy, how important not only for soil health perspective, but also energy as well as policy perspective. Thank you so much.
Thank you. Thank you. Thank you very much, Dr. Mohanty ji, elaborating on particularly the soil as resource. Now, the Professor Adarsh Palvik, who is a former chairman of Punjab Pollution Control Board, which is at the helm of affairs of all kind of pollutions, let it be soil, water, land, or any other associated pollutants. So I would like to have in your opinion about the reforms which have been done in terms of policy, in terms of intervention of science and technology, in terms of involvement of academia, research, and industry in solving these challenges being faced in by the society, by the country, by every citizen. Over to you, sir.
थैंक यू सर. सबको नमस्कार. तो सबसे पहले तो क्या ये वेस्ट कुछ चीज है और ये वेस्ट कौन बना रहा है? कभी हमने सोचा है? हम वेस्ट से वेल्थ, वेस्ट यूटिलाइजेशन, सर ने बड़ी बातें बताई. तो बस ये इतनी बात वेस्ट की क्यों बढ़ी? अर्लियर नोबडी वाज थिंकिंग इट एज ए मोड ऑफ पोल्यूशन. पहले यही होता था, एयर की, वाटर की, सॉइल की, यही पोल्यूशन है. एंड नाउ द वेस्ट मैनेजमेंट हैज बिकम ए डिजास्टर. पहाड़ बन गए कूड़ों के. तो किसने बनाए हैं? तो मैं, आपको पता होगा, तो मुझे लगता है ये सबसे पहले सोचना है, मैंने बनाए हैं. ह्यूमन. नेचर डज नॉट मेक एनी वेस्ट. It's human who has created this waste. Rather, I sometimes afraid of using this word waste. पर ये बन गया है, सारी एजुकेशन उसमें आ गई है, वेस्ट मैनेजमेंट में आ गए, सेग्रीगेशन, टेक्नोलॉजिकल ये इश्यूज. तो वो एक जबरदस्त पोल्यूशन बन चुका है. और फिर चलो आदमी कह सकता है भी थोड़ा सा वेस्ट तो होगा ही. टाइप्स, कैटेगरीज, अमाउंट, एवरीथिंग इज इंक्रीजिंग डे बाय डे. कोई रास्ता नहीं निकल रहा, कोई सोल्यूशन नहीं निकल रहा. बातें जरूर हो रही हैं, अच्छी बातें हो रही हैं, बट ऑन ग्राउंड नथिंग इज हैपनिंग. व्हाई? ये क्यों हुआ, ये भी सोचना पड़ेगा. बिकॉज वी हैव लेफ्ट आवर कल्चर. हमने अपना कल्चर, ट्रेडिशनल सिस्टम छोड़ दिया. चाहे वो घर की बात हो, चाहे इंडस्ट्री की बात हो, चाहे बिजनेस की बात हो, चाहे कमर्शियल एंगल की बात. जस्ट थॉट ऑफ यूर एंसेस्टर्स. अपने ग्रैंड पेरेंट्स को देखो, दे वर नॉट थ्रोइंग एनीथिंग आउटसाइड. या मैं सिंपल शब्द में पूछता हूं, आपके दादा नाना, उनके घरों में कभी डस्टबिन थे? बच्चे बैठे हैं. आवर सोसाइटी वर नॉट हैविंग एनी डस्टबिन्स. नाउ इन डिफरेंट बोर्ड्स वी आर प्रमोटिंग रेड, ब्लू, ब्लैक, समथिंग. इट मीन्स more dustbin means we are asking for more waste. And why? ये क्यों हो रहा है? Because we have followed the Western culture, economic culture, और कुछ भी कह लो, that is a developmental model, कुछ भी उसका नाम दे दो, अपना छोड़ दिया. अपना क्या छोड़ा? जो शुक्ला जी और बाकी लोगों ने बताया था, 3 hours, different hours. हम इतनी कंजर्व सोसाइटी हैं, अभी हम तो अपने घर से कुछ भी बाहर नहीं फेंकते थे. जो बड़े भाई के कपड़े हैं वो छोटा भाई, जो उसके शूज है वो छोटा भाई, पेन, पेंसिल, हर चीज. और अभी आपने देखा, सर ने बताया था, म्यूनिसिपल वेस्ट में कपड़ा आ रहा है भाई साहब. और किचन में से वेस्ट जाना तो मुझे लगता पाप है, और वो भी वेस्ट कर रहे हैं. फूड वेस्ट पाप है, हमारे ग्रंथों में लिखा हुआ है. तो अपना कल्चर छोड़ के, कौन सा कल्चर? यूज एंड थ्रो कल्चर. बाइंग मोर, यूजिंग लेस, थ्रोइंग मैक्सिमम. ये बात हो रही. दिस इज ए, ये मार्केटिंग मॉडल है, इकोनॉमिक्स मॉडल है जिसको। तो मुझे लगता है थोड़ा सा इस बात को समझना जरूरी है, इसलिए मैंने ये बात थोड़ी सी एज ए टीचर, एज ए एनवायरमेंटलिस्ट आपसे बताई है। तो सर ने बात बताई है, तो सोल्यूशन क्या है? अच्छा, फिर वेस्ट बन गया तो ठीक है जी, वेस्ट अपने आप में एक पोल्यूशन है। अब वो मैनेज नहीं हो रहा तो क्या हो रहा है? बर्निंग, ओपन बर्निंग ऑफ वेस्ट। एनजीटी ने 5,000 से 25,000 तक का फाइन रखा है फॉर हु इज कलेक्टिंग। वो तो खुशी से चल रहे हैं भी, वेस्ट मैनेज नहीं हो रहा तो जला दो, एक और नई पोल्यूशन, और कितना वो क्रिटिकल उसमें आएगा। और टाइप्स और कैटेगरीज में कभी आपने सोचा था भी बायोमेडिकल भी वेस्ट होगा? दे आर द हॉस्पिटल्स। कभी आपने सोचा था सीएनडी भी वेस्ट होगा? ठीक है, इंडस्ट्री से प्रोसेस चलाना है हमने, पर इंडस्ट्री यदि रीयूज रिसाइकल पे चलेगी तो वो नथिंग इज वेस्ट। तो मैं ये कहता हूं, नथिंग इज वेस्ट इन द वर्ल्ड, एवरीथिंग इज रिसोर्स। तो ये शब्द को रिसोर्स मैनेजमेंट यूज करना चाहिए। और सर्कुलर इकोनॉमी इज नॉट न्यू फॉर द इंडिया। सर्कुलर इकोनॉमी हमारे ब्लड में है। हम सोच रहे हैं शब्द हमने वो बाहर से लेके अपना, ये शब्द हमने दिया है। एवरी इंडियन, एवरी सिस्टम वाज सर्कुलर इकोनॉमी। कुछ भी शूज, कुछ बातें कर लो, छोटी छोटी बातें आपको लगेगा मजाक है, ये उस कल्चर को वापस लाना पड़ेगा, उसको ठीक करना पड़ेगा। मुझे लगता है ये चीजें हैं। बाकी सर ने पूछा पोल्यूशन बोर्ड में, वो कुछ भी वेस्ट नहीं होना चाहिए, ये रूल्स हैं, रेगुलेशन है। और उसके बाद ईपीआर आया, एक्सटेंडेड प्रोड्यूसर रिस्पॉन्सिबिलिटी आई। बड़ी अच्छी बात है भी, जो वेस्ट बना रहा है वो वापस लेगा। पर प्रैक्टिकली अगेन ऑन ग्राउंड प्लास्टिक इनोवेशन आई, नोबेल प्राइज मिल गया, बट व्हाट इज हैपनिंग टू द प्लास्टिक? केमिकल्स, फर्टिलाइजर, सब कुछ है, सॉइल की बात हुई। बट बातें, ये चीजें बुरी नहीं है। डू यू फील केमिकल्स आर बैड, मटीरियल्स आर बैड और प्लास्टिक इज बैड? द पर्सन, myself, the Adarsh Pal, who is misusing it, that is bad. Otherwise वो चीजें बुरी नहीं है। रिजिड प्लास्टिक हो, ये कुर्सी हो, कुछ दिक्कत नहीं है, बट यूज एंड थ्रो वाला प्लास्टिक है। एंड डू यू नो सिंगल यूज प्लास्टिक हैज बीन बैंड फ्रॉम 1 जुलाई 2022। पर कितना हम भी प्लास्टिक की बोतलों में पानी पी रहे हैं, और कितना इसके साथ अल्टरनेटिव्स हैं। सर ने कॉपर की बात की, ग्लास है, मेटल्स है, सारा कुछ है। तो ये कहां तक जाना है? So use of everything is okay, but misuse is causing the problem. So ये open burning EPR में targets बने हैं, certificates हैं, और उसमें on ground क्या हो रहा है? So बायोमास की बात आई, बहुत बायोमास, और पंजाब में खास तौर से पराली की बात थी। तो now we are doing ex situ management. मेरे पास पम्फलेट्स हैं, बाद में जिसने लेना होगा ले सकते। तो we are making pellets out of that. वो पराली से pellets बन रहे हैं, वो बॉयलर्स में जा रही है, गैस उससे बन रही है। ऐसी चीजें हैं जो कर सकते हैं। तो टेक्नोलॉजीज तो हैं, बट कैसे अडॉप्ट करनी है वो है। प्लास्टिक को खत्म नहीं, अल्टरनेटिव टू प्लास्टिक, जो क्लोथ है अपना, कॉटन है, जो जूट है, ये सारे अल्टरनेटिव पहले थे। पत्तल, जो पत्तल थे वो यूज नहीं हो रहे, और पत्तल वेस्ट बन गया, सारा लीफ लिटर वेस्ट बन गया। ये बायोमास अदरवाइज कभी वेस्ट नहीं था, उससे खाद बनती थी। दैट इज ऑर्गेनिक इन नेचर, वो कुदरत का रिसाइकलिंग है, सॉइल में उसको वापस जाना चाहिए। हमने उसको आग लगानी शुरू कर दी। तो ये कुछ चीजें हैं। और जो बायोडिग्रेडेबल मटेरियल है, दैट इज प्योरली ए कंपोस्ट, वो तो खाद ही जानी चाहिए। घर की सारी चीजें कहीं पशुओं को खाने में, कहीं पंछियों को खाने में, कहीं खाद बनाने में, ये अपने कल्चर को सोचो, उसको समझो, वो वापस लाना पड़ेगा। ऑल वेस्ट, जिसको मैं शब्द बोल रहा हूं, रिसोर्स मैनेजमेंट सोल्यूशन शुड नॉट बी टेक्नोलॉजिकल। बड़ी अच्छी बात है, सर ने बताई, बट लास्ट स्लाइड आपने देखी उनकी, सीमेंट कितना कॉस्ट है उसका? कॉस्ट इज प्रॉब्लम। हम प्लास्टिक रिसाइकलिंग, डू यू नो हाउ मच प्लास्टिक रिसाइकलिंग इज हैपनिंग इन द वर्ल्ड? बड़ी अच्छी बात है, प्लास्टिक 10%। और इन्वायरमेंट डे में 3 बार बीट द प्लास्टिक पोल्यूशन रिपीट हुआ है, थीम उसका। तो वो बुरे नहीं है, जो हमने उसको संभालना है या यूज करना है, हमें उसको देखना पड़ेगा। सो द बेस्ट वे इज रिकवरी, जो रिसोर्स रिकवरी, जो रिसाइकलिंग, ये सारी चीजें हमने पढ़ी हैं, उसको कैसे करना है ये देखना पड़ेगा। एसिड्स, बैटरीज, ई व्हीकल्स वी आर प्रमोटिंग, तो इट्स वेरी गुड। जो एसिड वाली बैटरीज तो हो रही हैं जो पहले हम यूज करते हैं, अब लिथियम बैटरीज आ गई ई व्हीकल में। ई व्हीकल से एयर पोल्यूशन कम हो रहा है ऑन रोड।
Kilometer of rural roads in Uttar Pradesh showcases its economic and environmental impact. From recycling waste to rejuvenating pavements and reinventing road repair, CSIR CRRI continues to redefine India's road future, innovating today for smoother, safer roads tomorrow.
So it's a short glimpse of CSIR, CRRI sustainable journey to facilitating circular economy in highway and infrastructure domain. So with the advent of these technology, whether it is a steel slag road, eco-fix, or the utilization of waste plastic in road construction, we have our presence in every domain. We have like launched the India's largest fly ash utilization mission in road construction domain, and presently facilitating around 12 million ton of fly ash annually in road construction. We are also facilitated the large scale utilization of waste plastic in road construction. These technology are just to providing an enabling media to facilitate the utilization of industrial waste, municipal solid waste in road construction domain, and saving our natural resources from rapid depletion. That's all from my side. Thank you.
Thank you very much, Dr. Satish Pandey. So you very briefly explained us particularly the resource constraint which infrastructure industry is facing in particularly the road construction, and the alternatives being made available to the construction industry, in particular to the road construction, by utilizing the waste generated from steel industry, by using the science and technology and the research R&D inputs, and being accepted by the industry in India as well as globally by the leading economies like US and in Gulf at Dubai. Thank you very much. So we have come to the closer of the panel discussion, wherein we very briefly discussed by the distinguished panelists on the waste generation from various sectors of the industry, and we discussed about इच्छा और आवश्यकता, जो भेद है इच्छा और आवश्यकता के बीच, वो हमें जागृत करना होगा, particularly the young generation, young kids. आज जो जैसा कि प्रोफेसर आदर्श जी ने बताया, आज जो ये समस्या हो रही है, एक समस्या है हमें अपनी इच्छाओं के ऊपर जोर नहीं है, कंज्यूमरिज्म बहुत बढ़ गया है, और जो सर्कुलर इकोनॉमी है ये इसलिए भी बहुत इंपॉर्टेंट है क्योंकि जो रिसोर्सेस हैं वो फाइनाइट हैं। प्रकृति ने, परमपिता परमेश्वर ने जो पृथ्वी दी है, पृथ्वी एक है, इसके ऊपर जो रिसोर्सेस अवेलेबल हैं वो भी लिमिटेड हैं, और हमारी इच्छाएं अनंत हैं। तो साइंस एंड टेक्नोलॉजी के इंटरवेंशन से, विथ इंडस्ट्री, with self-discipline and self-consciousness, will be in a position to achieve the economic path, the economic growth which our country, India, is looking forward, and we will be Viksit Bharat by 2047 by utilizing this by utilizing the intersection of science and technology and valorizing the waste being generated by all sector of industries. Thank you very much. We come to the end of the panel discussion.
Yeah, thank you, panel chairman and panelists, for I think for managing the lively discussion. I think now we will have the felicitation time quickly. Now I request Adarsh Palji to present a memento to the panel chairman Arvind Mishra ji. So I again request Adarsh Palji to present a memento to Dr. Manoranjan Mohanty. So I request again Adarsh Palji to present a memento to Dr. Satish Pandey. Thank you, Adarsh Palji. Now, huh? No.
I request Adarsh Pal ji to give memento to Lakshmi ji.
Yeah, thank you. So now it's time for the vote of thanks. So on behalf of organizing committee of the India, after this. Yeah, I request all the delegates to come onto the stage for the group photo. So I request Shukla ji, Sanjeev ji, Ashish ji, please come over to the dais to have a group photo with all the delegates of the circular economy. Please. Please come slowly. I don't know whether the stage is capable of having this many people. Shall we have? We'll stand and take. Stand. Come forward, everybody. Here. Can somebody keep the backdrop of IISF on the projection? So IISF background चाहिए हमको. So now the chief guests are available off the stage. Probably if anybody wants to have discussion, you can discuss with the chief guests. I request chief guests to be available at least for 10-15 minutes off the stage. Yeah. After that.